Welcome to This Explainer. Look, if you've ever tried to force an AI system to answer high-stakes business questions using complex, error-prone documents, you already know the nightmare we're talking about. Today, we are going to solve that. We're talking about transforming messy, intricate data into a strictly governed knowledge graph to build unshakable reliability for your enterprise.
So, what are we actually trying to build here? Well, we have to completely redefine our goal. We aren't just retrieving random isolated text chunks anymore. Instead, we are constructing a highly organized infrastructure of truth. Think of a governed knowledge graph as a durable memory, one that is firmly anchored in strict structure, verified evidence, and undeniable source authority.
Right, to build this enterprise system, we need a solid blueprint. Today, we'll be covering 6 key areas: the broken RAG problem, building the graph spine, taming OCR and entity noise, the immutable evidence ledger, expanding the corpus, and finally, reliable retrieval.
Okay, let's kick things off with Section 1, the broken RAG problem, and the absolute chaos of intricate sources. When you're processing complex, real-world sources, you are stepping right into the danger zone. You know the drill. OCR confusions, broken identifiers, corrupted names. I mean, imagine an AI authorizing a massive transaction simply because a smudge on a page turned a 5 into an S? No way. When your material is plagued by false spaces and page offset drift, basically an alphabet soup of errors, simple text extraction creates a totally unacceptable risk.
So this demands a massive paradigm shift. We absolutely must abandon chaotic, unstructured raw chunks that are completely blind to context and highly vulnerable to noise. The solution here is the clean, secure architecture of a governed graph. We're talking about corrected entities, exact page anchors, and immutable evidence ledgers.
Moving right along to Section 2, building the graph spine, where we extract the structural foundation.
Before we even attempt to read a single paragraph of body text, we have to define our exact building blocks, our graph primitives. It's a highly organized catalog broken down into structural elements like documents, entity elements like canonical names, and trust elements like evidence. This gives the entire system its structural integrity. It's kind of like laying down the steel beams for a skyscraper.
Now, to actually build this spine, we use a strategy called gold anchor extraction. Think of it literally like dropping a heavy ship's anchor. We establish our most authoritative structural layer first, like a formal index or a master register. We then convert that into our graph, require agreement between independent extraction tools, and queue up any unresolved anchors for a human to review.
Which brings us to Section 3, taming OCR and entity noise. Let's look at the correction and canonicalization engine.
To build the connective tissue for all this, we deploy an OCR-aware matcher. This is essentially one highly reusable engine that handles the whole shebang, from white space repair to symbol restoration and confusable character handling. It cleans up the mess automatically, which guarantees a shared, consistent entity resolution layer across every single document in your system.
Think of this engine as an automated triage system for your data. We feed in the clean lexicon, apply our OCR rules, and output canonical entity names. Crucially, it separates simple spelling fixes from complex semantic corrections. Anything even slightly ambiguous is deferred to a review queue. This keeps high-risk, uncertain values totally visible, instead of just letting the system guess and hope for the best.
All right, Section 4, the immutable evidence ledger. This is all about establishing provenance and source voting. To absolutely guarantee business reliability, we need to build a protective shell around our data. In this system, every extracted value becomes a claim, and each source acts as a voter within a very strict state machine. A claim might be confirmed, conflicted, or human-reviewed. Because of this setup, we never, ever lose track of where a piece of information actually originated.
And let me be clear, logging these exact metrics, it's completely non-negotiable. We're capturing the original value, the proposed value, the confidence level, and a direct evidence pointer. If a business decision is ever challenged down the line, this ledger acts as a transparent, bulletproof audit trail. It proves exactly why the system knows what it claims to know.
Okay, Section 5, expanding the governed corpus. Let's dive into body extraction and versioning.
Now, actually expanding the corpus requires immense discipline. We only, and I mean only, extract the body text after the graph spine is fully established. We segment the text, anchor those segments to our gold index entities, and then run them through our matcher. This ensures that every single new fact we extract is instantly tethered to authoritative proof.
All of this comes together in a carefully orchestrated build sequence. You go from defining your rules to extracting those gold anchors to building the early engine. But you know, the most vital cross-cutting discipline happens at step 6. You must constantly version the corpus and revalidate the graph structure every single time new corrections are accepted.
Finally, Section 6, Reliable Retrieval for Business. This is where we replace raw chunks with graph units.
So here is the ultimate payoff. Your retrieval pipeline should be pulling from rich, evidence-backed units, not just randomly sliced raw paragraphs. By serving up canonical profiles, claims with evidence, and relationship neighborhoods, your answer engine gains access to both the textual information and its vital relational structure.
So why does this actually matter for the business? Well, because feeding the answer engine, the canonical entity, alongside its source authority and its exact review state, effectively eliminates the hallucination risk inherent in intricate documents. It provides your executives and analysts with highly organized data that they can confidently act upon.
This quote really hits the nail on the head. The graph is the durable memory of what the corpus says, where it says it, how confidently it was interpreted, which authorities confirmed it, and which uncertainties still require review. Today, we've walked through quite the architectural journey together, moving away from the chaos of OCR noise and raw text chunks, building a rigid spine, taming entities with a correction engine, and securing it all with an immutable evidence ledger.
So, I want you to ask yourself, if your retrieval pipeline lacks an evidence ledger and a solid correction spine, can it truly be trusted with high-risk business decisions? I'll leave you with that provocative thought to chew on regarding your own data architecture. Thanks for joining me for this explainer.